Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with the commands cell, putmata, sample, drawnorm. These are very useful commands. Let's begin with this main data interface. Active is time press Control 8 for activating data editor and Control 9 for activating do file. So the first command is cell. This will temporarily invoke operating system. Let us clear everything and generate our data. And if we specify this cell, then this will invoke the operating system. And you can write here dir to display all the directories. Similarly, so let us take some time. str win word, and you see this will execute the word, but we don't want it to open it right now. Similarly, and then you can execute it. So if you write winexec, this means win execute, I guess. So that you can invoke a notepad as well. Open your notepad. You can open your do file, which is in notepad, and then again you can save. Now let us save this data by the name zzz.dta replace. We are saving it in an ordinary way, and let me run the directories. So we will have zzz over here, and let us rename this. Okay, rename this data by zzz followed by y and see it in our directories. So we don't have zzz y, so the change is made, but we have made this change or rename this directory or file of the data file by using the command cell. Now if you want to again rename it, so this is equivalent to specifying dot, this is equivalent to specifying exclamation sign. So this also invokes cell. So if you want to see it, if you write the exclamation sign and if you run it, you will get the same window command bar. Now let us rename this data and see it in there. We have renamed zzzy into 4x. So here is 4x. Now let me clear this and use this data that we have renamed and saved earlier. So this is the same data. Now we can again edit the do file using this command cell edit. We can again erase this data. Let us finally erase this data. It is 4x.dta, sorry, 4x.dta. Now we're going to delete it, making use of this command cell, and let us see check whether this really works or not. And if you run this there, you'll not find anything with 4x. And let me clear this and finally confirm this. If you use it, you'll not find the data or file. This is simple. Now let us go to our next command called putmata. We can put Stata variables into mata and vice versa, making use of this command. Now let us create our data set and then run this. Now if I write the command called putmata and asterisk means all, and replace, so this will, the existing variables that they will be put into the mata format, or they are now the vectors in their respective name, and putmata is specifying the variable names. This also does the same thing as the previous. If you see the results, three vectors posted. Now you can manipulate it. For the variable y, we are going to name it y, and for the variable ab1, we are going to name it by matrix x, and we are going to put it into the mata. And if you run this, so one vector and one matrix posted. So one vector is for y and matrix is for x. X contains variable ab and 1 is the constant of 1. Now let us see this, check whether those variables are created or not. So if you write mata a and int, so you will get this vector. Now this is a vector a. Similarly, if you write mata b, you will see the vector b, y, vector y, and the x is a matrix. You see this is a matrix, and this will be clear by this 1 2 3. There are 3 variables and 1 column. Now let us calculate the beta estimate. If we regress y on x, so let us calculate its beta, and let us display its beta using the mata. So this is the beta estimate. So this is the beta estimate. Now let us check this. Getmata beta force. So what is the result of this beta, we want to display it in our data set. That's why we are going to write force. And if you run this, so this is the beta set, and we can check it. Let us regress y and ab and list the matrix of beta. So we'll get the same thing for constant 1.41, for b it is 0.0039, and for a these are the constants. Now let us try another example. Draw beta, and then we generate certain variables and then format them in a nice way. Now let us, we have symbol number, these variables, symbol number, this is the sequence, un, a categorical variable of US and Nepal, and other variables a, b, y, c. Now we are going to put them into a mata format, symbol number and this categorical variable Nepal and US, y and x in the earlier, it's in the earlier way. Now we're going to put this into mata if un equals to 0 only for Nepal. So let us do this, and let us again calculate the beta estimates, beta coefficient, as well as this error, and let us in mata. So we're going to run a regression of Nepal only. So this is the result. We have calculated the error term as well. Now let us write getmata yhat id based on the unique identifier. This symbol number identifies our data uniquely. That is why we have written the term id and specified it is ASEAN symbol number. Now let us get meta. So this is the result after running the regression for Nepal only. If you see, if you sort un, you will get the result for Nepal. Let me sort un, and you see that is this regression. We have run a regression only for Nepal, and we have derived its error term. Now let's check. Let us run the same equation or regression using our ordinary way. So we regress it for Nepal, predict y1 if un equals to 0 for Nepal, and we order y asterisk anything that begins with it, and we get this result. Yes, and we want to see whether the value are same or different. So yhat1, we have derived this error term by using the regression in ordinary way, and we have derived yhat by running the regression using putmata command. Now let us, if we compare this, we'll get that they are exactly the same. So jointly yhat is equals to y1, they are 14, they are jointly defined, exactly defined, so they are one and the same. Now let us go to our next command called draw sample, draw norm. Sample is to draw more random sample, draw random sample without replacement. Now let us drop this and save this data in the name sample x data, use the same data, and then summarize. This will give us summary statistics. Now let us run the sample. Sample 15 means 15% sample, so 15% of 27. So is it 4? Yes. So 4 observations, it will calculate the 15% of the population. If we summarize it, this will create a summary statistics. By now we are clear what does our summarize command do. Now let us use our again the original data, and if we write sample 15 and count, specifying sample 15 only will result 15% of the population, but if we write count, that will result in 15 numbers or 15 observations each a sample. And if we summarize, we'll get the summary statistics. Again, let us use the original data, tabulate it by UN, by Nepal, and by US. By sort UN, we first sort by UN, and then again summarize and format. This will again create the individual summary statistics for UN and Nepal. Sorry, Nepal and US. Now if we write sample 30 by UN, so for each category in the UN, that is for Nepal and US, we are going to get 30% of them. So for 30%, 4 observations for Nepal and 4 observations for US. Now this is also equivalent to 30% of the total population. Now let us tabulate it by UN and then by sort. If we summarize it, the tabulation and summary statistics, we know about it. Now let us use our original data and then tabulate it and by sort UN summarize format. This is a repetition. Now sample 5 count, we are going to draw 5 observations from each categories, Nepal and US if possible. So 5 each, total 10 observations. This is fine. And again we'll summarize and tabulate. This is a very simple one. Now let us use our original data, tabulate it, sample 20 if un 0, if un is equals to 0, 0 is for Nepal. So for Nepal you will get 20% sample, and for US you will have all the observations. You see, for Nepal you are going to get only 20. If 20%, this is 20% of Nepal, and this is the entire US. Tabulate un. This is a very simple command. Now let us go to our next command called drawnorm. This will help us draw sample from multivariate normal distribution. This will actually help us create hypothetical data with the specified mean and variances. So let us create a matrix U of mean, D of standard deviation. These are two matrices, and we use our command drawnorm XYZ. Three hypothetical variables will be created, and the observation is 5000 with means 159 and standard deviation 118 and 7. Let us see whether we are able to get the variables with these parameters or not. Let us summarize and format, and we should get this result. In 149, here it is 159, 4.8. By rounding, you'll get the same result. 9, this is fine. Standard deviation 118 and nearly 7. Okay, these variables do comply with the inputs that we have specified. Now let us try another variation. Let us clear everything, and then we generate a matrix again. M for mean again, B is for variance and covariance, and matrix, let us list B. So this is our variance and covariance matrix. These are the variance, and off diagonal elements are the covariances. Let us display its determinant. It should be positive semi-definite, so it's positive, it's fine. Now we can use our command drawnorm. We are going to create three variables, 5000 observations, and the variance covariance matrix, and mean should be, it is specified by the matrix M and P. So let us see whether we are able to create those variables or not. Three variables are created, and let us summarize and format, and let us check what is the mean. 0.9 is equivalent to 1, 2, and 3. Mean is fine. Standard deviation, let us see the diagonal elements. 3, so this is a variance, right? Variance covariance matrix. This should be 3 squared 9, and then 2 squared 4, and then again 3 squared 9. Okay, we are fine with this. Now let us see this matrix list V and no we have done this. Let us correlate co B. We will get this result, exact result. So covariance, so 8.59 is 9 actually, and 4.578 matrix list V. We compare this to, if we run and compare this to all at a time, and it will be clear. So this is 9, fine. This is 5. This is our input. This is our input. Matrix B is our input, and we get this result from these variables X, Y, and Z. So 9, they are one and the same. If you round it, 5, 4, 3.9 is 3, 1, and 9. Yes, this is fine. Now let us try another example. We're now going to supply the correlation matrix, U for mean, D for standard deviation. Matrix R is the correlation matrix, and let us display the determinant of R. It should be positive definite. Yes, it is positive semi-definite. Okay, this will not disturb our result. And matrix list R no half. Okay, this is our correlation matrix. It's an input. Now let us use this command drawnorm X. Again, three variables will be created with 5000 observation. Mean should be, it is specified by the matrix U. Their standard deviation should be, it is specified by the matrix D, and their correlation matrix, it is specified by the matrix R. Let us run it, and we are able to get this three variables X, Y, Z again, and let us check. Now let us write correlate and check their means. Okay, correlate, and if we don't specify any variables, all the variables in the memory will be taken, and their means will be displayed. And let us check with the mean 149, 4.78 and 9. We are fine with the mean. Standard deviation, it's 1, this is 18, and this is 7, 118, 7. And their correlation, this is the correlation 1, this is 1. So let us list the matrix R, and again we can compare it. Let us list the matrix R. So this is the correlation of the variable X, Y, Z, and this is our input. Okay, 1, 1, 1, and minus 0.2, this is nearly minus 0.2, 0.45, 0.73. This is a very useful command. Drawnorm is a very useful command to draw hypothetical data by specifying the mean, standard deviation, variance, covariance, and correlation matrix. Before we end the tutorial, if you write asterisk review, this will give you the 5 latest commands that you have run. And if you write asterisk review, let me write it in command bar. So this is asterisk review. These are the 5 latest commands that we have run. And if you write asterisk review and specify some number, this will give so many numbers of commands. The latest command is I have run the do file, so all those commands are from the do file. Please take your time in understanding this. Thank you very much for your time. Thank you very much, Econometrics Melody.